So students, let us start with transient heat. Transient heat conduction means, see, what happens in steady state, everywhere temperature is constant, right? Transient heat conduction, temperature changes with the time. That's so there is a, so transient means in the heat conduction equation, heat conduction equation, equation, the component, the term dou T by dou T is not equal to 0, is a non-zero quantity. Right? Term dou T by dou T is a non-zero quantity. I'll write it like this. It's a non-zero quantity. That is dou T by dou T is not equal to 0. Fine. Now, when there is transient heat conduction, now let us take one-dimensional transient heat conduction. What is the one-dimensional transient heat conduction equation without, what is the one-dimensional transient heat conduction equation without heat generation? If I take, what would be the transient heat conduction equation without heat conduction? If you see, that would be d square T by dx square would be equal to 1 by alpha dou T by dou T, or dou T by dou T is equal to alpha into d square T by dx square. Agree? Or further going, dou T by dou T is equal to alpha is what? Rho Cp by K, is it not? Or K by rho Cp. K by rho Cp. K by rho Cp. Or K by rho C. We will not say Cp because we are talking about solids and liquids. Okay. Dou square T by dou x square. Correct. Now, now we have to understand this. When K is big, when K is big, dou T by dou T is faster. When rho C is big, dou T by dou T is slower. What does this imply? This implies the gradient of temperature. How the temperature gradient changes. I'll repeat again. This implies the rate of change of temperature gradient. Now, rate of change of temperature gradient implies the rate of change of heat transfer from a particular place. Higher the dou square T by dou x square, higher the dou square T by dou x square, what is more? Heat transfer would be more. Okay. Temperature is changing with x. Make sense? So this is how this importance is there with this particular equation. So when temperature, see, one of the things what happens is, if I increase the conductivity, if I increase the conductivity, dou T by dou T will be faster, and also it reduces the gradient slowly. The temperature change will become faster. That means the temperature of the whole body will remain almost the same. Have you written down till here, students? Now, write it. Dx square. Correct? Why? Because this one. Why I'm having dou? Why should I put it dou? Because t is also a function of time. T is a function of x as well as function of time. So I'm putting dou. If it was only a function of x, then I could have put d. That happens in steady state condition. Right? Agreed? Done? Next. Now, one of the things which is required here is, see, when you consider convection plus conduction, say let us take a particular sphere or a cylinder or anything, something round. Say here there is temperature T1, which is high, okay, and here there is temperature T infinity. Now this T1 will diffuse over here. Now tell me, here I will write T2. T1 minus T2 reduces as K increases, correct? T1 minus T2 reduces as K increases, correct? T1 minus T2 increases as rho Cp increases, correct? Make sense? Rho Cp is like, it's like this. See, if there is a slope like this, the slope, if I say a water reservoir is there here, okay, there is a water reservoir. Analogy here is of a water reservoir, and from the water reservoir there is a slope here. Okay, heat has to reach. The flow rate is told with respect to heat. Okay, the conductivity, how fast it is coming down, that shows how better the slope of that particular thing is. So the slope of the inclined plane is analogous. Slope of inclined plane is analogous to conductivity. Okay. Now here you think there are small reservoirs here, or it's absorbing. Maybe the this is wet. Sorry, there's a sand there, or there is soil there, which is pulling all the water. That, okay, the small reservoirs, the small pockets refers to rho Cp. Okay, and the flow rate of water is analogous to Q, heat transfer rate, Q dot. Okay. And then what else? Temperature, or you say the height of water, is analogous to temperature. Here the height of water is very high. As it flows, the height of water reduces. Correct? Because it's absorbing. And after some time it will go. I know. After some time it will go like this. In a steady state, it's a different case. I am not talking about steady state. I'm talking about transient state. So water will come out. There will be some Q here. What is the Q coming out of that depends on the temperature here, the height of that particular reservoir. More the reservoir, more the Q. So more the temperature, more the Q. More the height of the reservoir, more the flow rate, water flow rate. Similarly, more the temperature, more the flow rate. Second case. Temperature T2, sorry, the conductivity is to similar to the slope of the inclined plane. Slope of the inclined plane more, conductivity is more. Make sense? The flow rate of water is nothing but Q dot only. The height of the water, till where the height will come, that is temperature. Make sense? So here the height will reduce as it goes. Similar way temperature will reduce there. So this is a analogy of transient heat conduction to the flow of water out of a reservoir along an inclined channel. Make sense? You got the point? Think about it. Now this analogy comes into your mind, then you will get an intuitive understanding how to solve the problem. What we do, we remember only formulas. No, no, no. Formulas is there. Formulas anybody can put it. That intuitive understanding. Like yesterday's problem which was there. Yesterday we solved the 2022 problems. It was based on intuitive understanding more, less of your differential equations. So both together has to be there. So this develops the intuitive understanding. I hope you understand that. Higher the temperature, higher the reservoir. Higher the conductivity, higher the slope. So water will come faster. Makes sense? Exactly. It absorbs. Its temperature has to increase, the height has to increase, means absorption has to be less. If absorption is more, then the height of the water will come down. Similar way, if rho Cp is more, what is rho Cp or rho C? Rho C. We will not write rho Cp. Again and again I make a mistake. It's only for gas, rho Cp. It is generally rho C, is it not? Heat capacity of the solid as well as the liquid. Make sense? Think about it. Ask questions. It's much more involved and much more interesting. And this you will not find in any textbooks. This is exclusive to Ananth Pai classes. No, these kind of analogies are given, but they have not written it like that. See, no knowledge is, you say, we did not get knowledge just like that. But still, I can articulate it better. I can explain you better. That's it. And whatever seems difficult, I can make it easy. My skill is not about knowing a lot of things. My skill is about explaining you better. Write it neatly, student. This one thing will explain you about all the things about transitive connection. Done. Ram said no words. Rho C is rho is density, C is heat capacity. You know what is heat capacity? Specific. The amount of heat required to raise the temperature by a unit raised by unit temperature for 1 kg of the fluid. One. Done, everyone? Good. Good. Right. Neat. Exactly. Temperature difference is high. Heat transfer occurs faster. Exactly. Exactly. It's a slow process. So same thing. Water you can see, is it not? That's why I gave you that this one. It makes things much clearer. Similar thing. Water is something which is explained even in electrical. To explain electrical concepts, water itself is used, and these are analogous, very analogous. Because I don't know whether there is a theory of everything. People are going towards theory of everything. But one thing for sure, that in terms of differential equation, there is some analogy between all these transient phenomena, whether it's inductance, capacitance, everything has importance, and it has analogy in heat as well as in fluid. The same thing with our in quantum mechanics also. There is a lot of analogy. I know less of quantum mechanics. I have to say that I don't know much of quantum mechanics. I can pop up words like anything. Just like some of the greats, like Nityananda, pops up a lot of words. Is it not? He says that quantum technology, this vibrations, this, that, everything. Like that, I can say a lot. I know a lot of words, but if you see the understanding what I have, mechanical engineering. That's it. Done. Now next. Now one of the things here. Now water is coming here. Fine. Water is coming till here. Now it has to be carried away. Now the same thing, analogy I'm improving. Okay. Now when it is carried away, let us say there is a conveyor belt here or some buckets here. Okay. which is carrying away the water which is coming here. Getting the point? Now, if this conveyor belt is carrying the water away, that analogy is the H analogy. The fluid which is coming here with some velocity u and temperature T infinity is the conveyor belt. Make sense? And this conveyor belt is taking all the heat which is there only over here, not the one in between. What reaches at the end on the periphery, that only it is going to take. So the conveyor here is analogous to H or convection. Make sense? So when you take that conveyor, you can take, it is taking out all the heat. Or maybe in jog, you have air coming, and the jog falls is coming like this, but the air is taking all the water at the side. So the person who is below that thinking that jog will fall on his head, will fall somewhere else. Why? The air is carrying. But what air is carrying? What the river takes to the edge, only that air can carry. What is there in between the river, that air cannot carry. So what can this carry? This heat, this can carry only the heat which is at the periphery. It cannot carry the heat which is at the center. But then if it carries fast, then what happens? There won't be build up here. The heat transfer which is here, if the heat transfer here is slow, then what happens? There's a build up of heat at this point. If I have say something here like this, and this is carrying conveyor, okay, there is a wall here. Okay, there is a wall here. Okay, and this water, if this is coming faster and it is holding here, and this is carrying slowly, or I'll put a big wall here. Let me improve the this one. So let me have a big wall. Let me have a big wall and then a small hole through which it is flowing. Now the water which is going out here is lesser than the water which is coming from here. Then what happens? The reservoir height will come till here. The water which is coming out will be same, and the water which is taken out will be less. Then what will happen? Eventually this will go straight. The hole here is bigger, and this happens generally when Q is big or K is big. So relation between this K and H is very important. Between the conductivity and the heat transfer coefficient. That relation is what governs the temperature distribution here. Inside it, whether T1 is equal to T2 or T1 minus T2. How it is done. That is a convection conduction problem. If it is just conduction, then what happens? Eventually this T1 and T2 gap will reduce. There is no convection. What will happen at the end? This will go as straight. This will go down, this will go up, and at the end there will be one level it will reach. Similar way, T1 will go down to another say T3, and T2 will go to T3, and the whole will be T3 only. But here we are talking about heat being taken out. Water is going out. Makes sense? Write this analogy also. Conveyor belt, you write it. Which one? No, it's not insulation per se. Yes. I don't say insulation. The H, if it is not there at all, if there is, it's in vacuum, then what happens? H being not there is it is being in vacuum. There is no heat transfer if it is there in vacuum. H being there means there's heat transfer outside from the conduction. I want you to imagine if you understand intuitively everything you understand. So it's an interplay between K, H, and rho c. Wall is increasing means H. See, wall controls the H. Wall controls the H. That's wall controls the H. How much water can go out is if wall is not there at all, whatever heat is coming here will go out through the conveyor. What is going on? But if you say I will stop something, we will not have conveyor also. Okay, we'll say only this wall, and this is what conveyor. If you write in, it's okay. It's just for understanding. So if this is just a wall and it's going out, how much is going out based on this hole diameter? If the hole is bigger, whatever is coming is going out. If the hole diameter is smaller, or if it is closed, means you have a vacuum like we have here. It's a vacuum in between. So what happens? There's no conduction at all. There's no conduction, there's no convection, nothing. In this thermos flask, whatever there is inside and outside, there is a, see, this is one of the best examples. It's a two tin here is there. One is inside bottle, there's an outside bottle. Between that, it's a vacuum. It reduces conduction. The hot water remains hot for a long time. And the hot water remains at the same temperature all through. Getting the point? Now, wall represents this. Which wall? Which diameter? Whole diameter. Yes. 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 This diameter increases. If there is no wall at all, then what happens? Whatever is coming to the boundary, it is taken out. I think we should have some plates based on this. If we can devise these plates and explain these concepts, especially in engineering colleges, during cultural fests, okay, you develop a play and say this is the concept of heat transfer. I don't know, I write these plays down. But think we have to maybe in a local language only. If it is in this one in Mangalore, it can be Tulu. In Tulu, we can have a language, and then people think it is all not so good. Then you say this is how convection heat transfer happens. That's correct. So people will say, ah. Then afterwards, at the end, it has to come. You think what is this particular thing doing in engineering college? This is how convection heat transfer happens. Something like that. You have to think about it. Maybe I have given a seed now. If you can think and write it, see, giving idea is not big. Implementing idea is big. Anybody can just think. There was one person who is just sitting at a corner, katte, ಇದು ವಿಲೇಜ್ ಕಟ್ ವಿಲೇಜ್ ಅದಕ್ಕೆ ಹಳ್ಳಿಯ ಕಟ್ಟೆ ಇದೆ ಅಲ್ಲಿ ಕೂತ್ಕೊಂಡು ಏನೋ ದೊಡ್ಡ ದೊಡ್ಡದು ಮಾತಾಡುದು ನರೇಂದ್ರ ಮೋದಿ ಹಾಗೆ ಮಾಡ್ಬೋದಿತ್ತು ಅದು ಮಾಡ್ಬೋದಿತ್ತು ಬೈಡನ್ ಹೀಗೆ ಮಾಡ್ಬೋದಿತ್ತು ಹಾಗೆ ಮಾಡ್ಬೋದು ದೊಡ್ಡ 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 ಬಿಡುದು ಮತ್ತೆ in case there's somebody whatever he says Biden does it or any big person does it. You see, I told it, no, he's a local hero on that in the front of these 10 or 15 people only. He will keep on saying when he's till he's aged, he will say, you know what my ideas are, is it not? But that is local. The person who does has more value, and he does not talk at all. He keeps on doing those things. He does keeps on implementing. So there are two kind of people. One kind of people are the ones who just talk and who does not do. Another kind of people who do not talk but just go on doing things. But there are third kind of people. The category of Ananth Pai, who talks as well as does. Okay? Next. Then understand. Enough of self-boasting. Shall we go further? Yeah. Self-boasting is required. I have ingrained this quality now, purposefully for marketing sake. Chalo. Till I can employ a person who praises me outside, till then I should do my own praise. Then I'll employ a person who goes out and says how good I am. Okay. But the money I give, so they will go and do it. Okay. Ciao. Next. Now, what is it interplay between? It's an interplay between conduction heat transfer and convection heat transfer. Okay. Now let us do an analysis. Okay. Now we will go to differential equations and we will do the analysis. Okay. So now let us understand. Okay. There is something called Biot. Is it? There is something called Biot number. What is Biot number? Is internal internal conductive resistance. Very important, students. Divided by external convective resistance. Internal conductive resistance and external convective resistance, or it can also be said as external convective heat transfer divided by internal conductive heat transfer. Now this can be said as what is conductive internal conductive heat transfer. Internal conductive heat transfer resistance can be written as L by K A divided by, I can say, 1 by H A. A can cancel because it represents the same A. Agree? It represents the same A in conduction. Okay. So this can be equal to HL by K. Now the same thing we will do in convection heat transfer called Nusselt number. Nusselt number and Biot number is HL by K only. But in case of Nusselt number, K is not that of the solid but that of the fluid. Here it is a solid K, H is that of the fluid. In case of Nusselt number, this goes outside. This is Biot number, Nusselt number, K as well as H is the fluid itself. If I put Nu here instead of Biot number Bi, K instead of solid, it will go to fluid. That we will see the importance of Nusselt number later on. I'm just telling you all the things, so that at once it is coming, you will relate, you will remember that Biot number and Nusselt number has a similar thing. Okay. Now, if K is very big, what does it mean compared to H? This is comparison. L is constant. So what did I say? It is a comparison between H and K. It is a comparison between H and K. If H is very big compared with K, what does that mean? Conduction heat transfer is more. Convective heat transfer is less. If K is more, if K becomes more, then what happens? This will reach here. The water will reach there. But the hole here is smaller. Huh? Takes more time to for this to go out. So what happens? It will build up here. And what happens? The difference between the height and the reservoir to the height at this end will reduce, keep on reducing. It's transient, keep in mind. We are worried about transient, how it is moving. Is it not? So what happens? This distance will be very small. Whereas, if you consider h high and k small, then what will happen? Whatever is coming here is taken out. Make sense? Is it clear? So it's an interplay between HL and P. That is why if Biot number is equal to 1, if Biot number is equal to 1, then the conductive heat transfer and convective heat transfer rates are similar. Now you can know it is less than 1, greater than 1, you can get it. I'll say only this, Biot number is equal to 1, then conductive heat transfer and convective heat transfer rates are similar. Just like Reynolds number is equal to 1, what does it mean? Inertial and viscous forces are similar in magnitude. Reynolds number being 1 is viscous forces and inertial forces have almost the same magnitude. When Reynolds number increases, what happens? Inertial forces are more, viscous forces are less. When Reynolds number is very, very less, then viscous forces are more, like in the mantle of the earth, highly viscous forces in the earth's mantle. That is why the tectonic plates goes at a rate of how much? 0.1, sorry, point, sorry, 15 centimeters per year. Yes, tectonic plates. Tectonic plates means on the mantle of the earth. You know what is mantle? In the earth's core, say this is the earth's core. We don't know what is it. This is speculation because we have never reached there. This is the core. Then there is, it's believed that there is a mantle here. There is a molten iron here, and over this there is a crust. Crust is like, maybe it is not apple, not like apple, or maybe like that. Yeah, actually, they say that. You say earth, apple is smooth ಇದೆ ಅಷ್ಟೇ ಸ್ಮೂತ್ ಅರ್ತ್ ಇದೆಯಾ ಇಲ್ಲ ಮೇಲೆ ಕೆಳಗಿದೆಯಾ ಅಷ್ಟೇ ಸ್ಮೂತ್ ಇದೆ a polished ball, if you polish a ball, you cannot create as smooth as the earth's surface. Huh? Yeah, I do watch, you know that. And in that, this Neil, what is it? Forgot the name of the person. Huh? Neil Gristalis. So from there only I get it. See, I've told you my knowledge is not very, how do you say, I am not born with the knowledge. Knowledge I've acquired. And short, just like the flow is there, how the world is there, like that I am there. Correct? So, I am same as I am in the society. I am not somebody who sannyasa ತಗೊಂಡಿಲ್ಲ. So ಶಾರ್ಟ್ಸ್ ಅನ್ನು ನೋಡ್ತಾ ಇರ್ತೇನೆ ಅದರಲ್ಲಿ this is one of the things. Yes, it's very smooth. It's very, very smooth. You cannot polish and create that smoothness. You say Mount Everest is there. It's only how much kilometers? Around 8 kilometers. And what is the diameter of the earth? 12,000 kilometers. Compare 8 kilometer with 12,000 kilometers. It's like if you have 12 centimeter big one, then this would be around how much? 12 centimeter converted. Around 8 micron. Correct? Almost. Or 80 microns. Say. That is the level of the highest difference. 12 centimeters this big ball. So it's very, very smooth. Okay. So shall we go further? Done. This Biot number is now. If Biot number is very, very, very less, then what is more? Conductive heat transfer is more compared to convective heat transfer. Now I repeat again. If Biot number is much, much less than 1, what is happening? Conductive heat transfer is more than convective heat transfer. Now, when this conductive heat transfer is much more than convective heat transfer, what will happen to the temperature? This leads to very less temperature gradients. Temperature gradients inside the solid. Yes or no? So if temperature gradient is small, then what happens? There are if the temperature gradients if the temperature gradients inside the conductor is negligible, then the whole solid or the conductor can be considered to have the same temperature. It is like the reservoir and the last part is the same. It's not changing. So when the heat is taken out, everything drops. Observe here. This line is almost the same. As water is going out, this height reduces. So what happens as convection heat transfer goes, T1 is equal to T1 and T1 is dropping with the temperature. With the time, the temperature is dropping with the time. This kind of analysis or this kind of assumption is called a lumped mass analysis, where you take the whole temperature to be the same. Clear? Have you heard about lumped mass analysis? You can consider the whole mass having the same temperature. Okay, so the analysis of transient heat conduction assisted by convection. Yeah, if the temperature gradients in the conductor are very less, temperature gradient is less means what? Difference, the slope is less. Slope of the surface of the water is less. Okay? This slope is less. When this slope is less, then means what? The whole conductor here, T1 becomes almost equal to T2. So I consider the whole conductor to have the same temperature. There is no gradients. That happens when the conductivity is very high. A negligible temperature difference between the difference. Negligible temperature gradient implies negligible temperature difference. Correct? Small points to be connected. Fine. So, if the temperature gradient inside the conductor is negligible, then the whole conductor can be considered to have the same temperature. The analysis of transient heat conduction assisted by convection, which which considers the conductor to have to be at same temperature at any instant of time. The conductor, the entire conductor to be at uniform temperature. I will write uniform because same is uniform temperature at any instant of time. The analysis of transient heat conduction assisted by convection, which considers, wait a minute, the analysis which considers the entire conductor to be at uniform temperature at any instant of time is called the lumped mass analysis. It's called the lump mass analysis, lump system analysis. Whenever lump comes, then you have to say lump is everything is the same. It's called the lumped mass analysis, or it's also called lumped heat capacity method. Lumped heat capacity analysis. Important. On these questions have come a lot. And I'm taking more time for this purpose. Those questions are there, and nowadays the thing has happened is if you understand intuitively, then you can answer the gate questions. You cannot answer by answering previous year's question papers. Required, but not only based on previous year's question. This time new thing will come. You have to solve previous year's question paper to understand. Not that similar questions will come. It is not a university exam. University exam, it is difficult to ask question also. Why? Because syllabus is small. The syllabus is vast. Yeah. You ಕೇಳಿದ್ರೆ ಲಂಪ್ ಮಾಸ್ ಅನಾಲಿಸಿಸ್ ಅಂತ ಗೊತ್ತಿರಲಿಲ್ಲ ಏನಂತ ಲಂಪ್ ಮಾಸ್ ಅಂತ ಕೇಳಿದ್ದೀರಾ ಆಯ್ತಾ ಸರಿ ಇದು ನನಗೆ ಎಷ್ಟೋ ಕೇಳಿದೆ ನಾನು ಅದು ಏನಂತ ಗೊತ್ತಾಗ್ತಿರ್ಲಿಲ್ಲ ಟೈಮ್ ಕೊಡಲ್ಲ ನಾವು ಮೇನ್ ಪ್ರಾಬ್ಲಮ್ ನಮ್ಮದು ಇಂಟೆಲಿಜೆನ್ಸ್ ಇಲ್ಲ ಅಂತಲ್ಲ ನಾವು ಟೈಮ್ ಕೊಡಲ್ಲ ಅದಕ್ಕೆ ಬೇಕಾಗಿರೋ ಟೈಮ್ ಕೊಡಲ್ಲ and we don't get it. We all have the intelligence to grasp these things. Okay, so then next, this is called the lumped mass analysis. Okay, now here lumped mass analysis, very important one. Analysis is valid if Biot number is less than 0.1. Very, very important. lumped mass analysis is valid if by is considered to be valid by a lot of people. Yet professors when it is beta is less than 0.1. Now people will say, sir, why 0.1, 0.01? Yeah, you can do that. But what do we consider is important. What the world considers, that's important. Biot number is less than 0.1, it is considered to be lumped mass. Fine. Done. We have gone slow today. I'm sorry, students. I was that intuitive understanding I wanted to do, so I spent some time in his analysis, but it's okay. Now, I could have done it in 10-15 minutes, but I took more time to make you understand. Okay. So now, let us do the analysis. Okay. So now, let us consider a hot, say, hot steel ball. Let this be a hot steel ball. Here, air is there at T infinity. Hot steel ball is at temperature T, which is varying with the time because heat transfer is happening. Okay, so they with the H. Okay, so now the change in internal energy, change in, I'll write here, change in internal energy of the steel ball is equal to heat flow from the steel ball from the steel ball through convection convection due to movement of air correct. Now change in internal energy can be written as rho volume specific heat and change in time correct, or change in temperature. I'm sorry, change in temperature correct. Temperature is changing, so T1 to T2 it has changed. So what is a small change? dt d of T correct, dt. Okay, would be equal to what is the change heat transfer? H A T minus T infinity into d time correct. Simple. Here lumped mass analysis is valid. Here we have considered here lumped mass analysis or lumped mass assumption is valid. That is, the whole steel ball remains at the same temperature. Temperature is reducing. So temperature at the center and the temperature at the end remains the same. That is our assumption. That is why I can say rho C volume into rho volume C into dt. I can write it because it remains the same. Okay. So now doing this, I can write dt divided by T minus T infinity is equal to d is equal to d minus T infinity is equal to minus of, here it is minus because it is reducing, is it not? It is reducing, so minus, change is reducing, we are taking the heat is removed, so it's minus, dt is minus, that's what we consider, is equal to H A divided by rho C V volume into d, or I can say d of T minus T infinity divided by T minus T infinity is equal to minus HA divided by rho C volume dt. Makes sense? Simple. I can write it like that, is it not? Just think about it. Actually, gate coaching has to be such that you know this, we are just testing it. Now it is not like that. Teaching you from the basics. So it's like the whole engineering, we are doing it again. This gate coaching, I agree. Yesterday's Kochi person, they do only 4 hours per enough actually. If the basics is clear prior. But the problem is the basics is not clear. So we require, if I don't go like that, then you think you know, we think you know, but we don't know that you don't know, you don't know that you don't know. So at the end you will say, sir, class ಚೆನ್ನಾಗಿ ಮಾಡಿದ್ರು ನಮಗೆ ಬೇಸಿಕ್ಸ್ ಇಲ್ಲ ಏನು ಮಾಡಿ, you just blame yourself only. The lecturers in engineering colleges blame you. You also blame yourself. Okay. The PUC teacher blames you that your 10th standard your school is not good. Your school blames you that your previous, what you say, the primary was not good. The primary blames the kindergarten. The kindergarten blames the parents. This is what has happened. It is shifting of blames. Parents blame their parents. They blame the society. Blame came out. There is no solutions. We need solutions, is it not? So solution comes through Apex Academy only. That's it. Solution comes through solving the basics. That's it. Now, integrate. Integrating. We obtain. Integrating we obtain. Log of. Log of. Uh, Now here, one of the things what happens is, from where to where we have to integrate is important. Or integrating, let us put integrate, obtaining you will say integrating. Integration from, when you say d of t minus t infinity divided by t minus t infinity. From where to where we have to integrate? From t initial to t final. The initial temperature minus the final temperature with the time. So this is equal to integration of 0 to t time, what we are considering, minus of h a rho c v d t. Correct? So this I can write it as log of log of t minus t infinity from ti to tf. Ti to tf is equal to, or ti to t final, or t final t, or we'll put it as t. Let us not use t final. Let us put as t. T is varying with time. T is varying with time. So this is t is equal to minus of h a rho c v, does not depend on time. So I can take it outside. I can say h a rho c v into t. Or I can write t minus t infinity divided by ti minus t infinity is equal to e power minus ha rho cv into t. Very, very important. What is the number we have given till now? Number 17, 18, 19. Fin efficiency, we will give it as 20. Fin efficiency, we will give it as 20. And then we will give this as 21. This is very, very, very important. This is in fact everything. Now, what is A by V? What is A by V? Can be considered characteristic limit. Okay, that is right. You've written down till here? Finished. Let. Here I am going slow for the reason that this is the main thing. We'll understand tomorrow while we do problems how it works. No, we are comparing with the T infinity because it depends on T minus T infinity. So what? Why not? You have log of T minus T infinity minus log of Ti minus T infinity. What is that? It is log of T minus T infinity by T. We are looking for time, yes, temperature, time, temperature, yes. Here, here, why T? Because T minus T infinity comes from here. I cannot do away with the T minus T infinity. How can I do away with the T minus T infinity? Here, numerator dt, yes, I can say so. Yes, you are right. I could write with the dt only, and I can write. But then what happens? The log becomes a problem. You'll get log of. Huh? So what you'll get? Log of t minus t infinity only. Okay, so what? Yeah, another one. You have to create from it. Create from it. T is not a constant. Huh? T minus t infinity is not a constant. Just take t and see what is the problem you have. You'll get this. Exactly. Don't have to worry about it. You'll get the same thing whether you take dt or not. I agree. See what he's saying is yeah, because t infinity is a constant. Just like that we have written. See, we could have read dt by t minus t infinity also. What you will get here, this is log of t minus t infinity only you will get. What else? Keep. Chalo. It is for some people who are weak in mathematics like me to see that. Done. we understand it better. Okay, some number, unknown one. Hello. Yeah, good afternoon. Who's this? Sunshine. Okay. किसके लिए मैडम? Where are you from? You send me your details. I will call you later. You send me your details through this one. And what is your intention? Okay. Send me to the WhatsApp here. Okay. Same number. You send it to that. Okay. Then I will see. So, done. Now, now once this is done, now, now we know that. See, if you consider A by V, that is equal to, I can say, 1 by L, where L is the characteristic length. I will say it is the characteristic length. For sphere, for sphere, A by L or L is equal to V by A can be equal to, if you see it, you will get it as R by 3. You can check it out later on, where R is the radius. For cylinder, this will come as R by 2. For a cube of length, cube of side L, this comes as L by 6. You can check it out and see. Okay, cube of side length L, L is equal to, I'll say L is equal to R by 2. For this, L is equal to R by 3. For here, L is equal to L by 6. Clear? Now, let us understand what is Biot number. Biot number is HL by K. Okay. Now here, if you consider in this one, what we got, T. I'll write it in the next slide. Have you written this down? This is the characteristic. Where does this come? A by V. A by V comes as HA by rho CV. In that, A by V comes, and A by V is 1 by L. Correct. So like that, we are going to change the transient heat conduction thing. Okay, done. Now here, it's not done. Right. Done. Next. Now here, another part. So now, HA by HA by rho CV can be equal to, I can say, H by rho CL. Correct. And this, I will say, is equal to HL by HL by K, which is Biot number, into I have added a K, I have added a L here, right? So I will write here, in this case, I will write it as K by rho C, and L I have added here, so we have to write L square. And here we have actually time, I'm sorry, I will put time also. So we have into time, fine. In the exponent in the top you have time, is it not? So let me put a time here, fine. So now if you see this, I can write what is rho C, K by rho C. Okay. So I can write this as HL by K, Biot number, which is a non-dimensional number. And here this is alpha, which is the heat transfer coefficient, divided by L square into T. Yes, sir. Kadi, sir. ಆರಾಮ್ ಇರುತ್ತೆ ಬುಕ್ಸ್ ಮತ್ತೆ ಇಂದ ಬಂದ fine. Rho C. Now, what is alpha? What is the unit of alpha? Meter square per second. Now, what you are getting? Meter square per second. So, what is this? Non-dimensional number. Correct? So, what is this number? Biot number. This number is called Fourier number, which is a non-dimensional, where FO, where FO is the Fourier number, which is a non-dimensional time, which is non-dimensional time, given as alpha or T divided by L square by alpha. To understand in a proper fashion, people say alpha square by alpha square T by L square. You don't get the understanding there. Fourier number is T divided by L square by alpha, which gives you non-dimensionalized time. Make sense? So this is Fourier. Now therefore, we can write equation. What is that equation? 21 as, we can write equation 21 as, this is the next thing which we are doing. Now here equation 21 becomes, now equation 21 becomes T minus T infinity, that is the temperature difference now, divided by T minus initial temperature difference, I minus T infinity, becomes equal to exponent of negative Biot number Fourier. What is this T minus T infinity? If I write, if T minus T infinity is equal to theta, which is excess temperature, excess temperature, then theta is equal to theta I into e power minus Biot number Fourier. This is equation number 20. Easy. This is unsteady heat convection. Very, very, very important. Why important? It comes in here. Otherwise, also it's important because we actually deal with unsteady heat conduction only a lot of times. चलो, we'll stop it here, students. इतना तो हो गया. Tomorrow we will, there are some lumped mass analysis. Only questions have come in lumped mass analysis. No questions, but still we will do it. This time we will do everything. The heat transfer will not leave anything. Okay. Last time I did not do the other side. Okay, in the sense, I did not do Heisler chart and different types of things. I will just introduce. This time also I will not do much, but I will just introduce it to you, so that you will not say, okay, कुछ तो पता है. Now you will say, I don't know what is that. No, you know what is it, okay? But you don't know the depth of it. That's it. Till there I leave. Jai Shri.